linear pair postulate, isosceles triangle base angles theorem, CP, CTC. All of these are things we're probably going to be using in our notes for page 349. We're talking about solving problems with congruence, and so there are statements that we can make that will then tell us information. Let's try it with number 4 off of this page. I got something to write with, got some highlighters, do math in color, and let's go. Given ST is congruent to SR, color matters. So ST is congruent to SR. I'm going to draw a line through SR and through ST, just so we know that's what I'm talking about for congruence. Now, keep going. Segment TA is congruent to segment RA. Highlight this, different highlighter, different highlighter. There we go. The goal is to show how we know that angle T is congruent to angle R. So angle T and angle R are congruent. Yes, there's a formal way to do this, but I'm going to go ahead and just be very informal with my notes. I'm going to first of all start by drawing an auxiliary line. Auxiliary just means extra. It wasn't there. Extra, extra. Here it is. Draw an auxiliary line from S to A. Now, the reason that I can do that is I can actually separate this chevron shape or this arrowhead shape into 2 triangles, where SA makes the third side of both of them. So semi-informally, okay? We have ST and SR are congruent. That's a pair of sides. We have TA and RA are congruent. That's another pair of sides. And then because of this lovely little thing, the reflexive property, we're allowed to say that SA is a side of the top triangle, and it's going to be congruent to SA, which is a side from the bottom triangle. Yes, it's the same, and it's congruent to itself. That's the reflexive property. And I should highlight it pink. But because we're able to say that 3 sides, I almost said it 2, 3 sides of the triangles match, then that means that those triangles are congruent by side, side, side congruence theorem. So here it is. That means that triangle SRA is congruent to triangle STA because of triangle congruence by SSS triangle congruence. So if the triangles are congruent, then you know what? Doggone it, the pieces are congruent. That means that if we have actually proven this triangle is the same, then the other triangle on the other side is also the same. And so by CP, CTC, corresponding parts of congruent triangles are congruent. By that fact, angle T is congruent to angle R. Very informal proof. Certainly Mathia or my other lessons would make it be way more complicated, but if you can logic your way to the answer, you've done it. Question 4, done. Let's move on to question 5. Okay, suppose a broadcast antenna is on top of a tower, right? We've seen these. You see them on top of our hills as you drive around our freeways. A broadcast antenna is on top of a tower. The signal travels from the antenna to your house so you can watch TV. Consider the diagram to calculate the height of the tower and the distance the signal travels. Now, specifically, because this is a 30, 60, 90 triangle, find your 30, 60, 90 triangle card, or find the page when we did this example, and look for the relationship of 30 to 60 to 90. I've also got my highlight colors to add to the diagram on the paper. Please consider doing the highlight color on a stressful test question. Highlight the 30 degrees. Consistently, the 30 degrees is highlighted orange, which means the side opposite 60 degrees is also highlighted orange. Highlight the 60-degree angle pink, which means that the side opposite 60 degrees is highlighted pink. Pink, pink. And then last of all, green, or whatever color you're using. But the 90 degrees, highlight it green. And then the hypotenuse, the side opposite the 90 degrees, highlight that, the same color. The reason for doing all of that is that lets us know this is the proper arrangement of the sides of a 30, 60, 90 triangle. And then we can use this structure to actually set up our equations. So I'm going to write a root 3 and 2a. I guess I should also write 30, 60, and 90 on the paper. So if 60 and 500 line up, I'm going to put 500 in line with 60. And I don't know what this length is, so I'm going to call it x. But it's the height of the tower, right? We need to calculate the height of the tower. And then I'm going to put y on the hypotenuse. So x here, y here. That's the distance the signal travels. Let's add some color then into the problem. Pink doesn't need it for this here. The height of the tower, the distance the signal travels, that's green. The distance the signal travels, that's green. And then the height of the tower, that's going to be orange. Okay. Again, layering color all over this, that's how we process this problem. And until you've done this, like I said in the past, previous videos, broken record, 50 times, you got to do it. You got to make sure you set it up. Okay, I'm going to first of all solve this equation. Since this equation has a, root 3, and a 500, there are not two letters like how a and x are over here. I guess technically a equals x. I'll make all three equations. That's probably the smart thing to do. A root 3 equals 500, and 2a equals y. I'm taking how things line up, and I'm making equations out of them. Because that's the relationship here. We have a to x, a root 3 to 500, and 2a to y. This is the only equation with one letter in it. The other equations have two letters, so we got to leave those for last. We're going to solve this equation to figure out how big of a number a is. I'll do the work over here. A root 3 equals 500. We want to get a by itself. Divide by root 3. Okay, so when you divide by the square root of 3, over here, square root of 3 is being divided by itself. Something divided by itself is 1. Like 4 divided by 4, 1. 2 divided by 2, 1. Square root of 3 divided by square root of 3, 1. But other people have problems. I'm going to lay the blame on them. Other people have problems with the square root in the bottom of a fraction. So in order for them to figure out how to deal with the square root, multiply by that square root. Multiply by the square root of 3 to the bottom of the fraction, but that would make the fraction not balanced. So also to the top of the fraction. Now when you do that, square root of 3 and square root of 3 just becomes 3. And there's still, so like these two are working together, canceling each other out. There's still a square root 3 on the top of the fraction. But when you rewrite the fraction, rewrite this whole thing nicely, a equals 500 root 3 over 3. And then, knowing that a is this fraction, yeah, you could do a decimal value. Hey Siri, what's 500 times the square root of 3 divided by 3? Technology failed me right now. You could go calculate that. But x is that fraction. So now we have a value for how big x is. 500 root 3 over 3. Box it. And since a is this fraction, and in the bottom equation here, you have a 2a, we're just going to double the fraction. 2 times 500, 1,000. Y is 1,000 root 3 over 3. And we've solved it. Last one for this video. Wrapping it up. Let's get to it. This stamp is from Mongolia. Oh, hold up a second here. Move me off to the corner. About right there. Okay. This stamp is from Mongolia. Suppose that the longest side of this stamp is 50 millimeters. Determine the approximate length that the other sides of this stamp would be. You know what? This sounds an awful lot like a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, the sides across from the 45 are the same. The side across from the 90 is root 2a. So I'm going to write this structure here, 45, 45, 90. I can see that in the triangle's diagram. I can write a, and then a root 2 in our paper. The hypotenuse, green. So I'm going to highlight the hypotenuse green. I'm going to highlight the structure of this setup green. The sides are orange. So I'm going to write or highlight orange, highlight orange, highlight orange, highlight orange. And then I'm going to put some information in. Suppose the longest side of the stamp is 50 millimeters. Drop in a 50 mm for millimeter on the bottom edge. And then put 50 in line with A. This side we don't know. The other side is the same. We don't know it. So X there, X there. Now what we need to do is write our equation to solve for A. And then once you solve for A, that's the other missing side. So 50 equals A root 2. Divide both sides by square root 2. That'll cancel the root 2 on the right side. And it's not proper for us to have a square root of 2 on the bottom, apparently. So if I multiply by square root of 2, to the bottom first and then to the top, the square root 2's on the bottom will cancel. They'll work together to go away. Last like minute here. Here we go. So we really end up having 50 divided by 2 times root 2. A equals X equals 25. 50 divided by 2 is 25. Root 2. And we're done. Thanks for watching this video. See you in the next one.